All right, looking at section 10.6, the ratio test and the root test. Students will use the ratio test and students will use the root test. These are probably two of the nicest tests that we have to use. And that ratio test will be useful later when we go to talk about the radius of convergence and the interval of convergence. So what are other convergence tests? Well, we have the ratio test and we have the root test. The ratio test, we will take the original term and place it beneath a rewritten version, but any place we had a k, we replace it with k plus 1 or n plus 1. We will wind up with a number L. If that L is less than 1, then we say that it's convergent. If it's equal to 1, we don't know, not enough information. And if L is greater than 1, we say that it diverges. If we get infinity for an answer, we also say that that diverges. That makes sense because infinity is larger than 1. Use the ratio test to determine whether each series converges or diverges. Now, I did not leave us a lot of space here. You might want to work on a problem and then visit it again. All right, so we are going to use the ratio test. So I'm going to give myself a little bit of extra space here. I'm going to do letter A. So for the ratio test, I'm going to find the limit as n approaches infinity. This will be n plus 1 over 4 to the n plus 1 all over n to the 4 n plus 1. I'm switching my k's to n's in this case. I think that's the more typical nomenclature where you take and you do the math in terms of n, where the k is just kind of that counting value in the beginning. For part A, instead of dividing by a fraction, we are going to multiply by the reciprocal. So this is the limit as n approaches infinity, n plus 1 over 4 n plus 1, 4 to the n over. Now, we have 4 to the n, we have 4 to the n plus 1. Those are actually going to reduce, and I'm going to try to remind you that over here. So say I have 4 cubed, and this is 4 to the 4th. So I've got 4 times 4 times 4. On the bottom, I've got 4 fours. So I'm left with 1 4. So this is the limit as n approaches infinity. 1 over 4, n plus 1 over n. Now, if I put infinity in place of the n, I have infinity over infinity. I know that's indeterminate. So we can use L'Hopital. The derivative of the top and the bottom is both 1. I'm left with 1. And 1/4 times 1 is just 1/4. So if I come up here and check my rules, 1/4 is less than 1, so that we say my series converges. They said converges absolutely. You don't usually have to say absolute or conditional unless it's specified in the instructions. So you can kind of do that information what you like. So ratio test again. Limit as n approaches infinity, 2 to the n plus 1 over n plus 1, all over 2 to the n over n. Instead of dividing by the fraction, we're going to multiply by the reciprocal. 2 to the n plus 1 over n plus 1 times n over 2. Those n's are going to cancel out. So 2 to the n plus 1 is really 2 to the n times 2 to the first. The 2 to the n's cancel out. I'm going to put a 2 in the numerator. This is 2 times n over n plus 1. Again, if I put infinity in place of n, infinity over infinity is indeterminate. So that's not too helpful. So we can use L'Hopital. The derivative of n is 1. The derivative of n plus 1 is 1. So I'm left with 2 times 1. Now, 2 is greater than 1. So we're going to come down here. 2 is greater than 1. So we say the series diverges. Okay. Now, this guy, a little bit more confident in it. The limit is n approaches infinity. 3 to the n plus 1 over n plus 1 squared. all over 3n plus 1 over n squared. I've got 3n plus 4 over n plus 1 squared. And n squared over 3n plus 1. All right, there's a whole lot happening here. We've got n's all over the place. Truly, if I have infinity and I place in place of the n, I put infinity in place of the n, I have infinity over infinity. What we want to look at are the highest powers. So this is the limit as n approaches infinity. This would be 3n cubed plus 4n squared. This bottom piece, if I FOIL this out, n squared plus 2n plus 1. And if I multiply this together, I've got 3n cubed plus 6n squared plus 3n plus n squared plus 2n plus 1. All right. Again, infinity over infinity, L'Hopital, you could keep finding the derivatives. But before we talked about L'Hopital, we actually did a section where we just focused on the highest exponents. And that's what's happening in here, 3n squared over 3n squared. This will all be 1. When I'm all done, this whole thing is 1. Now, if I go back to the table, L is equal to 1. The test provides no information. Now, I would say this. Okay. Our instructions are to specifically use the ratio test. So we can say not enough info. If you did have to go back and show whether this one converges or diverges, you'd go back and do a comparison test. But we are not doing that. Apparently, you can compare it to another test. But that's a side note. We don't need to worry about that. And letter D, I have this exclamation point in there. So what does that mean? So your exclamation point is a factorial. So if you recall, 3 exclamation point is really 3 times 2 times 1. You multiply by 1 integer less each time. Anytime you see a factorial, I won't say anything. A lot of the times you see a factorial, that will actually be a ratio test. So this is 1 over n plus 1 factorial over 1 over n factorial. We want to multiply by the reciprocal, so this is n factorial over n plus 1 factorial. Now, what will this turn into? Well, I have a larger value in the denominator, so it's kind of like having 3 factorial over 4 factorial. But this is 3 times 2 times 1 over 4 times 3 times 2 times 1. Well, the 3, 2, and 1 are going to cancel, and so I'm left with that 4 in the bottom. There's a 1 in the numerator. So this actually becomes, I'm going to hop over here. The limit as n approaches infinity, 1 over n plus 1. If I put infinity in place of that n, this is equal to 0. 0 is less than 1, which is needed for the ratio test. So this converges. Absolutely. Yes. Okay. Use the ratio test to determine whether each series below converges or diverges. So I know I'm using the ratio test. Looks like this. Instead of dividing by a fraction, we multiply by the reciprocal. We'll hop over the problem here. I've done this in class where I've just kind of rearranged the lining up because we're multiplying. So I've put the factorials together and the exponent piece together. So I know the piece in the beginning, n plus 1 factorial over n factorial. This will be n plus 1. Then I have n to the n. I'm going to break the bottom apart with the exponents. So n plus 1 to the n times n plus 1 to the first. And the reason why that's pretty handy is because the n plus 1's cancel out. So now I have the limit as n approaches infinity, n to the n over n plus 1 to the n. I'm getting tired of this. This turns into something special. I know we touched on it somewhere, but we didn't really talk about it everywhere. I can rewrite this a little bit. Plus 1 over n plus 1. And if this whole thing is to the n power, you can divide all the terms by n. 1 over 1 plus 1 over n. Believe it or not, this denominator, when it's to the n power down here, this is e. So I'm left with 1 over e. Do you have to remember that it's that e value? You don't. It's kind of nice in a calculus 2 manner to recognize that that's e, and that has come across our plate once or twice. But the AP exam is not going to bring that up. And if it did, it would be such a minor detail. Don't even worry about it. So what do we need to know? Well, we know that this 1 over e is less than 1, which is good, but it's greater than 0. So we know that because it's less than 1, it shows convergence by the ratio test. Okay. Example 3, use the ratio test to determine whether each series below converges or diverges. I'm going to start out the same way. Limit as n approaches infinity, n plus 1 factorial over 10 to the n plus 1 over n factorial over 10 to the n. Now, notice, what did I not write? I did not write negative 1 to the k. I didn't forget it, but I very purposely didn't include it. Negative 1 to the k is either negative 1 or positive 1, or negative 1 or positive 1, or negative 1 or positive 1. These bars that I keep using actually have a meaning, and they mean absolute value. So you know about absolute value. When we talk about absolute value, we talk about the positive value of it. Distance from 0, distance is measured in positive way. So I don't have to include the alternating piece. This will become the limit as n approaches infinity, n plus 1 factorial over n factorial, 10 to the n over 10 to the n plus 1. And then we have some simplifying to do. I'll go to a little big here. This is the limit as n approaches infinity. The first piece is n plus 1. The second piece will simplify to 1 over 10. If I put infinity in place of n, remember that's our variable here. This is going to go to infinity. So because infinity is larger than 1, we say it diverges. I like the ratio test. It's very, very straightforward. Here's a rule and use it. And again, when you see that factorial, you will use that fairly frequently. All right, last two examples, root test. Use the root test to determine whether each series below converges or diverges. So here's the real crazy thing. If you have, it doesn't really show us very well. you have something written to a k exponent, you can take the k root of it and then just focus on the inside. Then you want to find the limit on the inside. So if that L is less than 1, you say it converges. If L is greater than 1, you say it diverges. And if L is equal to 1, the test provides no information. It's very similar to a ratio test. What do I mean by taking the root? So this problem for part A, I can rewrite as E over K to the K. This is K equals 1 to infinity. So what I'm allowed to do is I'm allowed to say, okay, what's the limit? I'm going to switch over to n's. As n approaches infinity of the nth root of e over n to the n power. I switch the case for n. Well, if I take the nth root of the nth power, those cancel out. And this becomes the limit as n approaches infinity of e over n. If I replace n with infinity, this is e over infinity. E over infinity is equal to 0. Come back to a list, less than 1, so I can say it converges. Letter B is already written to the k power, so you can find the limit as n approaches infinity of the nth root of 8n plus 3 over 5n minus 2. The nth power is n's cancel out. We'll put infinity in place. Oh, well, let's read it. The limit as n approaches infinity, this is 8n plus 3 over 5n minus 2. This is infinity over infinity. We can use L'Hopital. We can disregard the 3 and the -2, but I'd be left with 8/5. 8/5 is larger than 1, so we say diverges. Not too bad. Not too bad. And then I have section 10.7. I don't have a separate video for that, but basically it's the summary of everything. So that's been the conversation. How do I know what test to use when? Yep, it's a challenge. Just like when we first started to talk about derivatives, what derivative do I use in what situation? It was practice, practice, practice. And you got to know those. What integral do I use in what situation? Practice, practice, practice. That's how we got to know those. So unfortunately, with this unit being at the end, you don't have that same repetition over and over and over and over again. But honestly, it's just practice. Keep practicing. Keep looking up those flow charts. Check your answers. A couple of these have more than one way to solve them, but there's usually a best way. And consult the internet. If you're not sure where to start, consult the internet. Even if you put in the problem and it starts with, ratio test. Okay, I'm going to start the ratio test and go through the steps, but it really just does come from practice. So keep it up. This is tough. We'll get through it.